Using maths on the farm, it's the most important thing I think you can get out of your schooling.
We asked 4 farmers how they use mathematics on their farms.
Hello, my name is Fred Wilshere. I'm an irrigation farmer from the Collyambia irrigation area in southern New South Wales. On this farm we've been here since 1975, and our business is geared mainly around rice and wheat, clover for sheep production and for hay.
Okay, my name is Trish Williams and I live on a property situated in far southwest New South Wales, a very arid country. It's a grazing property, so we run merino ewes and we graze those for their wool.
Right, my name's Paul. We've got a property here in the, it's about a bit over 8,000 acres in the northern Riverina of New South Wales, about 6 hours drive directly west of Sydney. It's a mixed farming place. We grow cereals, run sheep, used to run cattle, but dry seasons have changed things around a bit. The last several years has been a bit difficult. We grow cereals, mainly wheat, barley and oats.
Welcome to our farm. This farm is located midway between Temora and Young in southern New South Wales and is a typical mixed cereal and grazing property, where you can see in the background we're running sheep and also growing crops. Approximately 5,000 acres involved in this property here, with about 3,000 acres of crops annually and about 2,000 acres of loose and mixed pastures for grazing enterprise. I find that I'm using maths every day in my farming operations here. I'm either calculating volumes or densities or rates, or doing calculations on returns or estimating distances. It would not be a day, I think, that I go past when I do not have to recall some sort of maths from school. And lo and behold, I find that most of our modern science is built on them, and a lot of our decision making is actually used in programming, and crop modelling is actually based on those mathematical equations. Probably the simple thing is it gives you a good sense of values, and it's a great way of thinking, a concept of actually being able to put things in proportion and valuing various inputs and outputs.
The main inputs are fertiliser, fuel, chemicals, labour, and then your contracting costs, like your harvest and if you've got to pay contractors. Now they're going to vary between paddocks, and they're going to vary every year depending on what's happened in the recent history. The level of input that's going to give you the best return per unit of input, and you're making decisions every day, and it changes on a daily basis because the season changes. No 2 seasons are the same.
Working with the banks, with finance, you need to know interest rates for your repayments, your borrowing capacity, whether you, when you're budgeting.
Yeah, in preparing figures for accountants, we use do quite a lot of work with spreadsheets, make all sorts of what-if decisions, and they can give you quite an insight into a different picture.
I'd spend probably 500 hours just sitting on a tractor a year. You don't spend that time in a trance. You're thinking things through all the time, and it means the difference between staying in business and giving it up, chucking it in.
Just some of the processes where we use maths on the farm might be when we're counting sheep. It could be when we're converting dip ratios. You need maths to work out your ratios, to work out your calibrations for your drenching guns, etc. We normally run 8,000 ewes on our property in a normal year. This year, because it's a drought year, we're down to about 4,000 ewes.
In the background here, you might actually, if you're very clever and can pick out, there's an odd ram, male sheep, amongst these ewes, and there's approximately 1 ram for every 100 ewes. That's joined at the 1% rate. And normally increase that number for maiden ewes. Young ewes require more rams, and we take that rate to approximately 2% to ensure that we get a good lambing percentage.
Measuring water, whether it's in tanks that we're storing or pumping water into for our stock. We're measuring the size of a dam or digging a new dam to work out how much water it will be will hold, and also when you're paying for it, you pay per cubic metre. Whether we're using it to mix up chemicals. When we're shearing, we need to work out the wool cut, how much wool each sheep is cutting on an average, and as to how much the wool is sold for and how much it costs to actually produce that wool. We know if you're fencing a 5,000 acre paddock or a 2,500 hectare paddock, you need to know how many star posts you need to know, how much wire you need to go around that paddock.
In farming, we're always looking for ways to save money and be more efficient. And one of the things that we have to do is build structures and construct things such as fencing and yards. And they're quite costly and can be very expensive.
Another example, I've recently built some silos. I made the choice to build them myself to save a lot of the labour costs. I've spent the last 2 or 3 years looking for a good truck, semi-trailer to cart on the grain locally, and I sat down and went through all the costs involved, the registration, the capital outlay, the tyres and the fuel, and my own labour, and decided that I'm probably better off contracting the cartage out and building more on-farm storage, which is what I did.
Here we have a wheat harvester, and in this particular case we're going to use some mats in order to replace this machine. We have to make a business decision about whether we should replace it or whether we should go on to contracting. The comparison there is that I have to buy a new machine, which is around about $500,000, and I have to work out whether the cost of ownership of that machine is better than actually paying some other individual to come in and do the harvesting on a contract rate.
Maybe share farmers on, you have to work out if you've got a share farmer that's doing some work, or if you're leasing part of your property or leasing property from someone else, you have to do all the maths to make sure it's a viable project for you.
Right. One of the ways we use mats, or mats is used in agriculture these days that people probably don't realise, is in the background you'll see a boom spray, and that is guided by what we call guidance or satellite guidance in the steering system, and that uses trigonometry, the basic principles of trigonometry, where we're receiving messages from 3 satellites, geostationary satellites, are recorded down, and that machine then knows exactly what position it is on the earth.
We find we use mathematics on the farm just about every day. A lot of the time we're not even aware of it. We also use it checking out weather data.
Okay, well the example we're going through now is that we've got a feeding exercise here. We're taking this bin out to feed some livestock, and we know that we need to give the sheep approximately 3 kilograms per head per week as a survival ration. What we need to know is to what rate is coming out of our bin, and we've calculated the flow rate by timing it over 1 minute. We now know then what the flow rate is per minute, and we'll work out exactly how many minutes we need to give to each mob. The process we're just going through now is trying to calibrate our boom spray, and I've timed for 1 minute the amount of liquid that flowed out of one nozzle and received approximately 700 mils in that 1 minute. I now know that I've got 56 nozzles on the boom spray, and I have to go through a calculation to work out the actual total flow out of the boom spray through a minute. Then I use that as calculation to work out my speed, into my speed, and that gives me a total rate per hectare. And that tells me how much water I'm going to require, and then from that I can work out how much chemical I need to add to the water to get the exact dose rate. So it's quite complicated mathematics, but you get used to it, you get very familiar with it, but you do need mathematics to do it.
In my school days, I would have never dreamt that I would be using maths in an everyday way that I have for the last, 30, 40 years, I suppose.
I would certainly recommend persevering with it, and because it's something that you use all the time, whether you want to or not.
I think maths is the most practical and useful subject, I think, other than communication skills and what you learn in English. But I use maths every day in decision making, just management decisions mainly. The day-to-day management choices that you make, that you use. And you're learning these skills in year 8 and year 9, I think. You mightn't realise you're doing it, but over time it becomes second nature. It just helps you in so many ways that you realise when you're a lot older.
So in conclusion, I find I'm using maths every day, and it is an important science to have a good grasp of. It's something that you might not see the value of at this stage at school, but I can assure you that in your later life you will use it and find it a very valuable tool and a very helpful tool.
A farmer where you grow crops, you need to use maths in everything you do.
Try hard, do your maths.
So stick with it.